Now, this is page 6 of the booklet. Okay? Okay, page 6 of the booklet, congruent triangles. Now, we did look at the four tests for congruence last lesson, and I've just shown them there, but I'm just going to read through this sheet, okay, so we can go through it again. Now, remember, congruent triangles have exactly the same shape and size, okay? So, and of course, congruent triangles, because they're exactly the same, you could rotate, translate, reflect one triangle onto the other. That's what we used to do in Year 8. We don't do that anymore. We don't say that's congruent to that because I'm going to slide it on top of it, or I'm going to reflect it on top of it. We're going to say, well, that's congruent to this triangle. Triangle 1 is congruent to triangle 2 because I know that I've got one of these 4 tests that I can prove. Okay, so just remembering before we do the 4 tests that if two triangles are congruent, then every matching side will be equal in length and the matching angles will be equal in size. And because the 2 triangles will be identical, they'll have the same areas and everything like that, okay? Now, to prove that 2 triangles are congruent, we just need to do one of these 4 tests. And the first test is if 3 sides of one triangle are equal to 3 sides of another triangle, then the 2 triangles are congruent, and that's by rule SSS. So if you look at the first triangle here, we've got single dash matches with single dash here. The double dash there matches with the double dash there, and the triple dash side matches with the triple dash side there. So those 2 triangles are congruent by SSS. Test 2 is the following. If 2 sides and the included angle in one triangle is equal to 2 sides and the included angle of another triangle, then we've got SAS. Now, the important thing here is that the angle is the included angle. Please, you might want to highlight that on your sheet. It is important, more than important, it's absolutely necessary that that angle is between the other 2 sides. So I don't want to see it written as ASS or SSA. It has to be SAS with the angle in the middle. Notice we've got single dash side there, double dash sides there that match, and we've got the angle in between that is equal. The third test is AAS. All right, the third test is AAS, where you've got 2 angles in one triangle and another side in the triangle, of one triangle, is equal to exactly that same thing in another. Now, girls, it doesn't matter where this other side is, as long as it's in the same position. So notice I've got an angle with a dot and an angle with a dot, an angle with a cross and an angle with a cross, and in this case, the other side is between those 2 angles, but it didn't have to be there. Let's say I rub off those dashes there and I put a dash down here, right? Let's say I put a dash down here. Where would its corresponding dash be on this triangle? That dash I've just put opposite the cross, or I've put it between the dot and the blank angle. So where would it go in the second one? Yeah, opposite the cross. So I could have the dash here and there, or I could have the dash, let's say I put a double dash here opposite the dot, then the double dash would go here opposite the dot. It's not 2 sides. It's not 2 angles and the included side. It's 2 angles and any other side. But the sides have to be in matching positions from one triangle to the other. Okay, so we've got SSS, SAS, AAS. Doesn't matter where the side is, but as long as it's in the same position for both triangles. And the last rule is RHS, which is right angle. So they're right angle triangles. The hypotenuse both have a single dash, so they're the same. And then another side is also the same. So this test is RHS. All right?
If there was a question where I had a right angle but the hypotenuse was not in the hypotenuse, was on either side of that, would that make it SAS?
Yes. Girls, you can have, not every right angle triangle is going to be RHS. So you could have, I might just draw that here for you. So here is an example of a right angle triangle that is not RHS. So I could have a right angle here. All right, yep, I'll move it down. I can have a right angle there and let's say a right angle here. I can have that this, sorry, don't want that. I've got this side is equal to that side, and I've got, let's say, this angle here with a cross is equal to this angle here with a cross. Actually, that's not making sense, is it? Well, look, this particular one, oh no, all right. Well, if I had it like that, it could be AAS, couldn't it? Angle, angle, side, right? If I had this case here, right angle, I could have this side and this side and that side and that side, and what would this one be? This would be SAS. This one up here would be AAS. So just because you've got a right angle, don't automatically think it's RHS. Remember that the hypotenuse is opposite the right angle, okay? So in neither of these cases do I have the hypotenuse that's marked out, okay? All right, girls, what we're going to do now is we're going to do some formal proofs, okay? So last lesson, when you did exercise 10.7 on your sheet, you were just picking one of those 4 reasons. Is this SSS? Is it SAS, AAS, or RHS? So just looking back at that homework from last lesson, which was these sheets, you were stating whether, you were stating which test was being used. So that's what we did last lesson, okay? I'm just remembering with question 3 that AAA is not a congruency test. Okay, so many people make that mistake with question 3. Those 3 equal signs like that means it's congruent too. So they are not congruent because AAA is not a congruency test. You'll later learn that it's a similarity test. And you also did these questions. All right? So did anyone have problems with the homework that they want to ask about from last lesson? Like with question 4, 5, 6, etc.? No? All right. What we're going to do, okay, now if we look at this, girls, can you read that from up the back? You've got your sheet as well. All right. Just remembering, girls, AAA is not a test for congruent triangles. So if 3 angles in one triangle are equal to 3 angles in another triangle, it does not mean that the triangles are congruent. All right, now I'm going to do a little picture of that just to show you. I did do, for example, some isosceles triangles. Oh no, I think I did an equilateral triangle last lesson, but let's say I do a triangle like this, where this is, let's say, 90 degrees, 30 degrees, 60 degrees. And then I decide to do another triangle here with exactly the same angles of, I know it doesn't look right, 30 degrees, 60 degrees, 90 degrees. All right, the sides are different lengths. All right, so these 2 triangles do have 3 equal angles, but they're not congruent. One's obviously not the same size as the other. I can do some isosceles triangles, for example. Let's say this is 40, then what, and if this was isosceles, what would these 2 angles down here add up to? They'd be 140, so half that, they'd be 70 each. But then I could draw a much larger triangle there with the same size angles. Now, if you want, you can draw one of these examples on your sheet showing that these triangles are AAA, but they're not congruent. They're similar, okay? So you might want to draw the second set or the first set of triangles, and you'll say that these are not congruent, okay? They are similar. All right, girls, now, we did talk about this briefly last lesson as well. When you name congruent triangles, the vertices must be given in matching order. So remember how, for example, I've got the dot here at C and the dot there at Z, and the arc at B and the arc at Y and the cross at A and the cross at X. So if I go A, B, C in this first triangle, I'm going cross, arc, dot. I must do the same here, cross, arc, dot, and I go X, Y, Z. All right, so as you do your proofs, we're going to put little symbols in the corners of the angles. And when you name your angle at the end, it's got to be in order. Now, we did practice a little bit of that last lesson. Now, when we do congruence proofs, I want you to follow these 5 steps. Step 1, identify the triangles that are being used. So, for example, for this one, you'd say in triangle ABC and triangle XYZ. Don't write that yet. We're going to practice this like 50 times. Right? Then steps 2, 3, 4. You know how each congruency test has 3 pieces of information? SSS, SAS, AAS, RHS. Well, that's steps 2, 3, 4. You'll be either doing SSS, RHS, SAS, or AAS. All right? And then in step 5, we have to say, therefore, triangle ABC is congruent to triangle XYZ, and give me which of those 4 reasons it is. Okay? Now, it says here, so girls, let's say I'm working with this triangle here on the left and that triangle here on the right. All the information about the left triangle should be on the left, and all the information about the triangle on the right should be on the right. That's what that means. Okay. All right, girls, we're on page 8. All of this top section is exactly what I have said before. Just a few things, they're the same steps as before. This was just someone else's worksheet that I've taken. We've said put everything about the left-hand side triangle on the left, everything about the right-hand side triangle on the right. When you state parallel lines or if one of your reasons is alternate angles on parallel lines, corresponding angles and stuff like that, remember, whenever you're stating alternate angles or stuff like that, you've got to put on parallel lines. But instead of saying on parallel lines, we're actually going to say which lines are parallel, but you'll see that in the examples, all right? Just some symbols here. The symbol for is parallel to is those parallel line symbols. The symbol for perpendicular is that right angle type thing, one line and then the other one going across. Okay? The symbol for congruent is 3 equal signs. The symbol for therefore is those 3 dots like that. Do you know those?
Yes.
All right, so just focusing on those symbols. Are you okay with all that? The symbol for parallel, the 2 parallel line things. Perpendicular is congruent to is like the 3 equal signs, and therefore is those 3 dots. Now we're going to do our first proof. All right, I'm off the screen a bit, so I've got to go back up. All right? All right. Okay, girls, here we go. Here's our first example. I'll just move it up. Are we ready? Okay, here's our first example. So step 1, identify the triangles. We say, girls, the idea here is that we're trying to prove that triangle JKL is congruent to triangle MNL. Now, I'm not sure about the order there. So our first step is in triangle JKL and triangle NML. Let's see what we can do. Notice we've got some markings on the diagram that KL equals LM. Now, so we've got KL equals, I would actually say ML, but it doesn't matter. So KL equals ML. How do you know that? Because of the lines, because of those dashes on the diagram. When anything's given to you, that was given to you, that information, you say given. So you write given. You know what? I'm going to do it in red pen. Actually, you can take this copy when I'm finished. Yeah, so if someone gives me a red pen, all right? Did you? Okay, so step 1 was to write which triangles we're in. That was step 1, okay? Then we've got our 3 facts. The first fact is that KL equals ML or LM. That was given because the marks are on the diagram. Okay, what else? Now it says that angle JKL is equal to angle NM. Oh, I can't read it. All right, look. JKL, this one, is equal to which one, girls? This one. By what? Equals LMN. Reason, now don't write parallel lines, this is what you'll do. You write alternate angles, comma. Instead of writing on parallel lines, which takes a long time, why don't we just do the symbols? JK is parallel to MN. That's much better than writing on parallel lines. Can I have a rubber, please? Okay, so just do this in red. Okay, so we've got given there. So girls, from now on, no more on parallel lines. Of course, you have to state that the lines are parallel, but you say, so girls, what I'm going to do as well, I'm marking on my diagram the information I've got in another colour. So we've got that those sides are equal because they were given to you, that these angles are equal, alternate angles, JK is parallel to MN. You must put the parallel bit, but don't write on parallel lines. Do it in mathematical notation, okay? And the last one, you could do parallel lines again, but what have they done? KLJ, they've done this one with NLM. So what have we got? Yeah, those two. So KLJ is equal to angle NLM, reason vertically opposite angles. And of course with those, I don't want any abbreviations here, girls. The only abbreviations you're allowed to do are the equal sign, an angle, a triangle, the parallel symbol, but not writing parallelogram. You don't write L-O-gram. Okay, it's only for parallel lines, perpendicular, equals, angle, triangle. The only symbols, so therefore up here, the only abbreviations that I want you to use are stated actually over there. They are, that's parallel, perpendicular, equals, congruent, angle, and triangle. I don't want to see any other abbreviations. Parallel, perpendicular, equals, congruent to, angle, triangle. Nothing else. No parallelogram looking like this, parallelogram. All right? Lines, parallel lines, no. If you want to use parallel, you say JK is parallel to MN. All right? No other way. Okay, girls, so I've marked in my information in another colour, right? So can you see which test it is? So we say, therefore, triangle, they've done this first one for you, JKL, which is blank dot arc. So this should be the same, is congruent to blank dot arc, NML. What's the reason?
AS.
Good. A. And is the side in the matching place? It's between the two angles, isn't it? Yep. So it's correct. So we've got AAS. Okay? Now, actually, girls, down here was the information. Sorry. Can you see that? Okay. Down here was the information given in the question. So I meant to tell you that. I'm just going to pause this video for a minute. So, girls, the only rules that you will use were given on the front page of the booklet, all right? So you had all those rules about vertical opposite angles, alternate angles, all those other rules. You will use any of those rules in those 3 steps, okay? Now we're going to look at example 2. Now in example 2, this is the information given that EG, so the line EG bisects DF. Now we know that it bisects DF because this equal marking here and there, so we know that DG is the same length as GF. Bisects, what does bisect mean? Cut in half. So bisects means cuts, so EG cuts, oh, it means cut in half. So EG cuts DF in half, okay? That's what bisect means, cut in half. And we've also got that EG is perpendicular to DF. Now that information's given on the diagram, and you have to prove that triangle EGD is congruent to triangle EGF. Now girls, we're obviously starting off with some fairly easy examples. They will gradually get harder, all right? So remember, step 1 is to state which triangles we're in. In triangle EGD and triangle EGF. Notice everything about triangle EGD is on the left here. I've put this triangle on the left and the other one's on the right. It's best if your triangle's on the left to keep that on the left, and anything about this triangle's on the right. Don't go swapping sides, otherwise you're going to you confuse your brain. So we know that DG equals GF. Why? You can put that EG bisects DF, or it was marked on the diagram. You can put given. Let's say the markings weren't on the diagram. The other thing you could say, or you could say that EG bisects DF. Now, the only time you will say given is if the marks are on the diagram. Girls, they actually, wait, you know what? I wouldn't say given, because does it say DG equals GF to you? Like if you look up at example 1, it says KL equals LM. That's given. I know these markings are on the diagram, but they did not tell me DG equals GF. I know it's marked. They've told me EG bisects DF. I'm going to cross this given off, and I'd rather you say EG bisects DF, because there'll be times when they do just tell you that, but they don't put the marks on the diagram. And let's start getting ready for year 11, girls. All right? Okay, the next one. We've got that angle EGD equals angle EGF, which equals 90 degrees. Now, I know the symbols are on your diagram, but the reason you know that is that EG is perpendicular to DF. You know, when two lines are perpendicular, they meet at right angles. And I'd rather you put that than say given. So EG is perpendicular to DF. Now, that's when you're allowed to use that abbreviation perpendicular, is perpendicular to. All right? And we also know that EG is a common side. Now, sometimes I write EG equals EG in brackets, common side. So this is what I've got. Those sides are equal, so I'll just do them in red. We've got this angle, and this is a common side. I'm going to put a double dash on that common side because that side belongs to both triangles. So, girls, this is not RHS just because it's got a right angle. What rule is it? S? Angle side. So those two triangles are congruent by SAS. Now let's just make sure that they've done these in the right order. EGD goes, well, I suppose it goes down that common side to the right angle and along the bottom, so it should be EGF. Okay? So it is. EGD is congruent to triangle EGF, and the reason is side, angle, side. Girls, again, we've got the double dash there, so side in both triangles, another side, and that angle is between. Look, side, there's the angle, there's the side. Side, there's the angle, there's the side. Okay? Example 3. Okay? Okay, in this first example, again, step 1, identify the triangles. In triangle TPS and triangle TQR. All right, you can see that. See here, we've got that this is the given information down here, that PQRS is a rectangle. Now, because we've told you it's a rectangle, you can go and tell me any property of a rectangle in your proof. All right, you know with a rectangle, what do you know? Opposite sides are equal. All the angles are right angles. That'll probably, yes, all right. Opposite sides parallel, all the angles are 90, opposite sides are equal, so we can use any of that information. And we're given that TS equals TR. Can you see that that's actually given? They've spelt it out. TS equals TR. So in these triangles, we've got TPS on the left and TQR on the right. That TS equals TR. Why? That was definitely given because it's written down there. Then we've got that TPS equals angle TQR, which is 90. Now, that's not given. Why do you know that they're 90? Because, yeah, but you don't just write property of a rectangle. You put angles in a rectangle. Yeah, you can just put angles in rectangle are equal to 90 degrees. Okay? That the angles in a rectangle are equal to 90 degrees. Okay? We also know, now, with this last one, we know that PS equals QR. It's not given. Why am I saying that PS equals? So, good. So let's put the double dashes. Opposite sides of rectangle are equal. Okay, you don't have to say equal in length. I think we know they're equal in length. So girls, these are my 3 pieces of information. That was the first piece with the single dashes, that was given. The second piece is that I've got right angles there, and the third piece of information is that these opposite sides are equal. So what have I got? I've got right angle. Do I have hypotenuse? Yes. Do I have another side? So yes, so therefore TPS is congruent to triangle TQR. Look, to know which order to name them in, I've gone along the side with no marks on it and then gone along the double dash side. Do you see what I'm saying? So to make this in the same order, I've gone along the side with nothing on it and then down the double dash side. So therefore we go TPS, no markings, double dash, no markings, double dash, TQR, they're in order. Reason, RHS. Okay? Now for the next one. Example 4 on page 9. So we've got, this is the given information down here. It wasn't marked on the diagram. We've got that XZ equals WY. Now I'm going to mark that. You know why it's not marked? Because they overlap. Now, this is what I'm going to do with this triangle, girls. There's nothing worse than overlapping triangles when you're trying to prove congruence. So you really should draw them separately. So I'm going to do them over here. That's my first one, and I'm going to go WXZ. So whenever you've got two triangles, you need to draw them separately, if they're overlapping, that is. See, these didn't overlap. And the other questions did not overlap, but I've clearly got overlap in this triangle. The reason they told you that XZ equals WY and they didn't mark it, if they put a mark here, you're going to think that Z to that point is equal to Y to this point. So that's why they haven't marked anything on the diagram, because they can't, because they've got intersecting lines. So whenever you've got overlapping triangles, I need you to draw them separately. Then you'll mark the information on it, then it'll be clear, and then you won't make a mistake. So there's my first triangle, which is that one, and my second one's down here, and I really hope I've drawn the right ones. So I've got XWZ and I've got WXY, and they are the correct triangles. So you're trying to prove that those two are congruent, so you draw those two. Nothing else. All right? You draw the two that you're trying to prove are congruent. So let's mark the information on these two separate ones now. XZ equals WY. So XZ, that one, equals WY, that one. Now, why am I saying that XZ equals WY? Was it given? Yeah, it is. It's given there. So it's given. They've also told us that WZ equals XY. So do these with two dashes. WZ equals XY. That also has been given. Now, yes. Girls, now go back and look at your diagram up here. WX is the same as WX here. So I'm going to put three dashes on those sides. Got it? They're the same. WX, WX, it's the same thing. So that is a common side. So therefore, they are congruent by SSS. Do you notice that you could not put those dashes on that diagram? Because you can't go putting a dash along XZ because there's an intersection there. So you have to draw them separately. And believe me, when you come to do similarity proofs and all that, okay, so when you come to do similarity proofs and everything, it is much better to draw them separately. Okay, so please, if they're overlapping, draw them separately. Okay, so I think we've had one of each type there. We're going to do some more examples now. Okay, girls, we're just going to work through a few more, or actually you can try a couple. It's exercise 10.8, question 1. A and B from your textbook. Girls, actually this is the Year 9 textbook we're working from, and next week we'll start on the Year 10 textbook, because both textbooks have congruence in them. It's just that it's a little bit more guided in the Year 9 book, and then when congruence is done in the Year 10 book, it's not really guided at all. Okay? So, exercise 10.8, the first question, completing those proofs. Okay, do you want to have a go? I'll let you have a go. Okay, in exercise 10.8, question 1A, we know that EF is equal to EH, and that was given. Okay? We know that FG is equal to HG, and that was also given. And we also know that EH is a common side, so I'll put three dashes on that. So therefore, triangle EFG, so I'm going along the single dash side to along the double dash side. So do the same, single dash side, double dash side. So EFG is congruent to EHG, triangle EHG, and the reason is SSS. In the second one, girls, these are fairly easy because a lot of the information is already given, but they will get harder, all right? So in triangle ABC and triangle EDC, we've got that BC equals CD. Given. Okay, we've got that AC with a double dash. Notice it's going from that corner into the centre, so try and do this one the same way. Is equal to EC. That's also given on the diagram. And we've got two lines crossing here, girls. We do not have that AB is parallel to ED. We don't have that. We've got two lines crossing, and when any two lines cross, you form vertically opposite angles. So therefore, angle ACB is equal to angle ECB. So I've gone along the double dash side to the corner and along the single dash side. So do the same along the double dash side to the single dash side, that those two angles are equal because they are vertically opposite angles. And so therefore, girls, what's the reason? It's SAS. So those two triangles are congruent by SAS. I need them in the right order. A, B, C. I've gone along the blank side and the single dash side. So blank side, single dash side would give me EDC. So triangle ABC is congruent to triangle EDC by SAS. Next question. Question 2A. Okay, now this one's not guided. But you are given that angle QPS is equal to angle RPS, and you're given that PS is perpendicular to QR. You have to prove that triangle PQS is congruent to triangle PRS. So we can say in triangle PQS and triangle PRS, what have we got, girls? Well, we've been given some information. What have you got? Angle QPS is equal to angle
RPS.
Yeah, so QPS equals RPS. Reason?
Miss,
Given.
But we already stated that. Do we just?
Yes, you have to say it again. You need... Okay, the second piece of information is that we know that we've got right angles here. So angle PSQ is equal to angle PSR, and they're both equal to 90 degrees. Sorry, I don't need a bracket there. And the reason is that, what, PS is perpendicular to QR. When two lines are perpendicular, they meet at 90 degrees. And now other information that I can just see is that we've got a common side. So you can, if you want, go PS is common, or you can go PS equals PS, common side. So some people like doing that. So girls, what do we have? Two angles and a side. So therefore, triangle PQS is congruent to triangle. Let's make sure we've got it in the right order. So we're going from blank, sorry, we're going from dot blank right angle, dot blank right angle. It's congruent to triangle PSR, and the reason is AAS.